Alright, this video is going to talk about what we call a sequence. A sequence of numbers is just a set of numbers that follows a pattern. The nice part about a sequence is, unlike a function, functions we plug in anything we want. So a lot of times the domain is all real numbers, might include fractions and decimals. For a sequence, the domain is the integers. We only ever plug in nice round either whole numbers or sometimes negative numbers. Also, a sequence can be finite or infinite. It can have a lot of terms, or it can have a finite number, a limited number of terms. So you'll notice down here at the lower left, I've got a sequence, a sub n equals 7n plus 2. The major difference between a sequence and a function is what it looks like. We use this a sub n to represent the fact that if I want to find the first term, well, a sub n represents which number the term is. So I'm going to plug that 1 in for n here. To find a sub n, plug 1 in for n, and I end up with 9. But if I wanted to find a sub 5, well, I would just take 5 and plug it in for n. So if I want to find the first 5 terms, I'm going to plug in 1, I'm going to plug in 2, 3, 4, and 5. But again, you'll notice a sub 1 means n was 1. The value of a sub 1 is 9. It's sort of like when we used to plug in x and find y. Now we're plugging in n to find a sub n. A sub n represents the output. So you'll notice these terms in the middle, I've got a little bit different sequence here. A sub n equals negative 1 to the n plus 2. Well, if I plug in 1 through 5 there, you'll notice what we get called an alternating sequence. Negative 1 to a power. Well, negative 1 to an odd number always comes up negative. So we get the same answers for 1, 3, and 5 here. But negative 1 to an even number comes up positive. So therefore we get the same two answers. Again, positive 1 plus 2, positive 1 plus 2. The same two answers for a sub 2 and a sub 4. So again, we call that an alternating sequence. Take a second. There's a little bit bigger sequence over here at the right. But see if you can't fill in all of the n's. A sub 1, 2, 3, 4, and 5. Find the first 5 terms of the sequence given here. Alright, well here's what I ended up with. When I plugged in 1, well 1 minus 1 is 0. So again, negative 1 is going to start off being to the 0 power. So notice, unlike over here, when I plugged in 1, it was negative 1 to the first. All those odd numbers happened right there. Well, this time, positive 1 turned to 0. 3 turned to 2. 5 turned to 4. And basically, we got positive 1 on the top of all the odd terms, terms 1, 3, and 5. I got my negative 1s in the even terms. 2 minus 1 was 1, and 4 minus 1 was 3. Negative 1 to the third stayed as negative 1. So you'll notice we kind of offset things by putting that little minus 1 in there. It kind of pushed one term kind of forward. My negative numbers happened on my even terms. My positive ones are going to happen on my odd terms. Now at the bottom, much more like the first set, 2n minus 1 looks very linear. I'm going up by 2's minus 1. Notice I got a 1, a 3, a 5, a 7. I got those odd numbers. Because, again, they're increasing by 2's. Right? I noticed 1, 3, 5, 7. Well, hey, on the next one, I fully expected to get 9. And again, you can plug in 5. 10 minus 1 would be 9. And you can definitely see that. Well, one thing we want to be able to do is find the terms. Another thing we want to be able to do is write the sequence, or what we call an nth term or explicit sequence. Again, I believe your book often will refer to it as an nth term sequence. Could we write the pattern? Take a second, think about the two patterns down below here. See if you couldn't notice a couple of things using what we learned on the last screen. How would you write the sequence for these terms? Well, here's what I came up with when I looked at these sequences. I noticed in this first sequence that I went from positive to negative to positive to negative. I want to go back and forth. There's that alternating sequence idea. So I put a little negative 1 to the n minus 1. Now the reason I did the minus 1 was, again, when I plugged in term a sub 1, I wanted to end up getting a positive number. Well, negative 1 to an first power would have been negative, so I need to take that 1 minus 1. Or as you'll notice in number 6 here, I want to end up with negative 11. Well, negative 1 to the 6 minus 1 would be negative 1 to the 5th. And that's going to stay negative. As it goes, same thing. I notice I went from 1 to 3 to 5 to 7. There's that odd pattern again. When I plug in a number, I want to go up by 2's. every time n went up 1, 2 times that's going to go up by 2's. But I want to get the odd numbers. I got to subtract 1. Such as, again, if we look down here, 2 times 6 would have been 12. But again, minus 1 is going to give us 11. So again, I'm going to end up with negative 1 times 11, or basically negative 11 is termed a sub 6. Over here at the right, kind of the same idea. I noticed on top it was powers of 3, so I said 3 to the nth power. On the bottom it was powers of 2. 2 times 2 times 2, and 2 times 2 times 2. 2 to the 4th is 16 on the 4th term. So if I put 2 to the n, that means that when I take 2 to the 4th, I'm going to get that 16 that I'm looking for. However, on the top, notice I wanted to start at 1. Well, that's really 3 to the 0 power. So when I plug in 1, right, I need that to turn to a 0. So I went and said n minus 1. I'm one term off. I didn't start at 3, 9, 27. I started at 1, then 3 and 9 and 27. So again, when I plug in 4, 4 minus 1 is 3. 3 to the 3rd is going to give me that 27 I'm looking for. And again, there is my 4th term. Again, two things we can do with sequences. You can find the terms, or you can find the sequence. It's really about pattern recognition. Try to see what pattern is happening from term to term. One other pattern we just want to mention very quickly, we haven't seen it for a while, is called factorial. Remember that factorial really just means if I want 5 factorial, I'm going to take 5 times 4 times 3 times 2 times 1. I'm going to multiply from the number I'm given times every number directly below it, or notice up here, sort of that sequence idea. I'm going to start with n, then I'm going to multiply by 1 less than n, then 1 less than that, and 1 less than that, all the way until I reach 1. So if I wanted to find 10 factorial, I would want to multiply 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, and frankly, I would much rather use my calculator for that. You'll notice I can do that on my calculator. I want to type in my number, so notice I already typed in 10 factorial, but let's go ahead and do it again here. I'm going to type in 10, then I'm going to go to my math menu, and I'm going to go over to PRB over here on the right, probability. Number 4 is the factorial, or that exclamation point. And if I hit enter, it'll handle all that multiplication for me. 362,8800, 3,628,800. You'll notice factorials get very large very fast. Well, that was a pretty big factorial. It's not the biggest, but a very big factorial. What is the smallest factorial? Kind of a neat thing of factorials, again, you can't just plug in all the integers. You can actually only plug in the positive integers. So the smallest possible one would be 0, which you would think, well, hey, that's just 0. But remember, we have to multiply our way down to 1. So I can't start at 0. I'd be multiplying my way up. So we just define this one. Not only is 1 factorial equal to 1, but 0 factorial equals 1. It just makes the math make sense. It makes everything work. But again, that's factorial. So watch for that pattern as well when you're talking about sequences. Now, another type of sequence that we can deal with is what's called a recursive sequence. A recursive sequence is more, a lot of times, what we think. It's how we think. Because recursive sequences work their way from term to term. Whereas an nth term sequence, like we said, if we want to find the 5th term, we just plug in 5. Well, if I want to find the first 5 terms of a recursive sequence, I can't start with the 5th one. I have to start with what I was given. So notice I've got a sub 0 equals 3 right here. We would call that the first term. Now, if I want to go find a sub 1, what I'm going to have to do is say, well, a sub 1, when n is 1, is equal to a sub 1 minus 1 then. If n is 1, I have to plug in 1 for n. But notice in the sub number, not the value, but the sub number, that means that what I want is actually to find a sub 1, I need to take a sub 0 and add 5. I'm not just plugging in 1 and calculating numbers. I have to plug in 1, figure out what number I actually need. A sub 1 equals, well, 3 then, plus 5. A sub 0, remember, was equal to 3, which means a sub 1 is 8. To get a sub 2, again, 2 minus 1 would have been a sub 1. I'm going to take my previous term, a sub 2 and a sub 1. Well, a sub 1 came before that. So I'm going to take my previous term, which again was 8, and I'm going to add 5. So I'm going to end up with 13. And oftentimes a sub n minus 1 is just called exactly that. It's the previous term, or the term before, right? And minus 1, it's like saying if I'm on step n of a staircase, well, step n minus 1 would be the step right before it. So again, to find a sub 2, I need to take a sub 3 minus 1, right? 3 minus 1. So to find a sub 3, technically, I got to take a sub 2. Or basically, to get a sub 3, I need to take the previous term, 3 minus 1, so a sub 2, and add 5. Well, that means 13 plus 5 is 18. And to get my fifth one, technically a sub 4, right? 0, 1, 2, 3, this will be the fifth term. I need the previous term plus 5. Basically, I need 23. 18 plus 5. Another way to look at that is a sub n plus 1. Now, whatever term I'm on, n plus 1 would be the term after that, right? A sub n would be step, let's say it's step 10. Well, 10 plus 1, that'd be step 11. So to find a sub 4 in a recursive sequence, again, I can't just plug in 4. The problem is if n is 4, well, that's going to find me term 5. Or even if I wanted a sub 4, I need n to be 3. Well, I don't know a sub 3. All I know is a sub 0, but I can work my way up. If a sub 0 is 2, well, a sub 1 then is essentially a sub 0, right? The term right before it, squared. So 2 squared would be 4. Again, a sub 2, if n is 2, or sorry, n plus 1 is 2, well, that meant when I plugged in 1 for a, then 1 plus 1 would have been 2. I know it's a little bit different way of looking at it, but again, if I want to take a sub 1 squared, that'll be 16. Maybe an easier way to look at it is start on the right side here. If I squared a sub 2, well, that means that n was 2. That's going to find me a sub 3. So if I take a sub 2 squared, that'll get me my 256. And again, if I want to find a sub 4, I need to take the term before it, squared, and I will end up with the slightly larger number. Again, these go big quick sometimes. 65,536. Again, those are recursive sequences. You're working away from one term to the next by plugging in the previous term. So again, a little bit different way of looking at things. One of the most famous recursive sequences is what's called the Fibonacci sequence. The Fibonacci sequence is actually sort of a double step. If a sub 0 is 1 and a sub 1 is 1, well, to find any term, right, I need to take the term n minus 2, 2 steps back, plus a sub n minus 1, the term 1 step back. So to get a sub 2, again, 2 minus 2 would have been 0. So this is going to be a sub 0 plus 2 minus 1 would have been 1. Well, a sub 0 was equal to 1. A sub 1 was equal to 1. So a sub 2 equals 2. And again, that's just a coincidence that n and its answer end up being the same. The idea was we plugged in the term a sub 0 that was 2 steps back and the term a sub 1 that was 1 step back. So to get a sub 3, again, I need to take 2 steps back plus 1 step back. Well, that's 2 plus 1 or 3. To get the fourth one, I need 2 steps back plus 1 step back. Well, 2 plus 3 is going to be 5. And again, same idea. 2 steps back plus 1 step back. 3 plus 5 is 8. Again, it's a very famous sequence. If you want to know more about the Fibonacci sequence, you can talk to your teacher or just look it up. There's a lot of fun things to do with sequences. Good luck. I hope that helps you with your homework. If you have any questions, make sure you talk to your teacher. Otherwise, have a great day.